So we know that the clock is regulating a lot. We know that circadian disruption is a fact of life. What we do at the moment, including me, is you set an alarm clock to wake up. First thing we do is look for tea or coffee or a cigarette, and that wakes us up rather than the circadian clock. And then at night, we all rely on a glass of wine or sedative hypnotics to put us to sleep. That's not the way we should be doing it, because none of this is actually fixing the clock. None of this is actually working with the physiology that we need to be working with. So in my lab, we've been thinking of ways in which we can then go in, understand these pathways, and therefore fix the clock. For this, the main system that we've been thinking of is to try and copy what light does, right? Because light is the most important signal to the clock. How does light speak to the clock? And can we copy those pathways to then make new drugs, for example? So by understanding those pathways, we then get a handle on how nature shifts the hands of the clock, and therefore can we copy that and make ways in which we can shift the hands of the clock. So what does light do? So what we're studying in my lab is when that light information is picked up by the eyes and sent to that SCN, what is the SCN doing with that information? And how does that molecular information eventually converge on clock genes and change their expression? For example, one study that we did in the past is to say there must be some reason why the effect of light on the clock doesn't go on forever. And that answer is probably there if we try and understand what's happening in jet lag, because we've all experienced this, where if you fly to a new time zone, if the effects of light on the clock were not limited, we would all be there in the new time zone the next day as soon as we saw the sunrise. But that doesn't happen. We take several days to adjust to a new time zone. So what we did is to expose mice to light at a time at which they are not expecting it. So light at night, so this is, for example, if they had taken a flight west, they were seeing light at night. And then we took the SCN and looked at the gene expression landscape of what was changing. We found lots of genes, but I'm just going to condense what we found down to the fact that light information goes in through neurotransmitters and switches on the expression of this clock gene, PER1, which is the same one that we met at the very start of the lecture. And PER1 is what goes off and shifts the hands of the clock. But alongside PER1, what we found is that there was also another gene switched on called SIC1, or salt-inducible kinase 1,